All right, so the project continues. So let's take a tour of what we've invented. So this is the end product. Um, it's a big box. It's full. It's got some cyclones in there. It's got, remember that in that last video I talked about, it separates the big stuff and the small stuff. Well, this is it. So let's take off the lid, right? So you can see you got some some geometry in there. But there's a lot of parts, right? This thing's all loosely held together. So we'll remove the hull here. Now you can kind of get a glimpse. So you got debris that is going to enter through this that orifice there, and then it's just like a pipe. It just goes straight down, right? Just goes straight down, and this whole area down here is like, I know it's like a cave. This whole reservoir just holds all the big stuff, right? Now it doesn't spin, it doesn't do anything fancy. It just throws it straight down. So all the big heavy stuff, dog hair, Lego, it all just sits here at the bottom, right? And so that's kind of half the trick. Is it's going to come in at high velocity, and you want it to smash into the bottom. And when it comes in and it smashes into the bottom, that's when it's going to throw a lot of debris all over the place. Let's get rid of this sketch here. It's going to throw a lot of debris all over the place. And so that's where, and we'll remove the sidewall adapter assembly. And so you've got air. Where does the air go once it comes in, right? Where's that negative pressure? Well, the negative pressure is actually this right here. So you'll see that it's like a lid, right? So let's see here. What is this object? We'll take the lid off, right? And you can see that you have 3 air inlets here, right? So you've got this kind of channel. I'll put the lid back on, right? And you can see it's going to intake the air through there. And this is where we'll install that wire mesh. We'll melt it into the top of that piece there. So we'll print that piece. I've already printed a test piece to make sure it would work. And so we'll print that at 100% infill. It's not very big. That way we can melt that little mesh into it. So let's go ahead and turn that off. And so you got the air going in there, and that's where it's going to start doing the magic, right? The cyclones are going to start spinning up. And so let's take off this lid here, because this is where the negative pressure is. So you can see that we now have this kind of like chimney style, right? And we're pulling, there's negative pressure pulling air out of the cyclones through the middle of them, right? And so let's remove the cyclone lids. And you can see there's the cyclones, the inside of them. I made in all of my testing up to this point, it's been 2mm thickness cyclones. This is 4mm thickness. I think we want it to be rather rigid, and we don't want vibrations and oscillations influencing kind of the capturability. So here, from some of our best tests, this is a nice smooth gradient cyclone. Similar to, when you go to like the mall or something, you see those you throw the coins inside of the coins spin around all the way until the middle, and then they fall in the middle. Similar concept, right? So similar geometry, but nothing alike, right? So that's that. So let's go ahead and remove the cyclones here. And which one? There it is, cyclones. Let's remove the cyclones. So now here we have that chimney. This is the negative pressure chimney. And then we have this cyclone kind of repository. So we have a second reservoir here. Now, why did we have a second reservoir? Because, and I don't know how Dyson and them do it, but oh yeah, look at that geometry. That is flawless. Got to get in there and clean that up a little bit. I know it caused that too. I don't know why I did it that way. So I'm going to have the second the reservoir here to hold the dirty stuff, the very, very small particulate. And the reason I'm going to do that is because I don't know how to better separate the capture of this and not have it enter the bin and then enter this loop, right? And maybe that's how Dysons work. Dysons are just constantly looping the light particulate over and over and over through the cyclones. I'm going to try it without that, but I can also just remove this whole thing if I need to. So that's that. And now let's remove the chimney piece, this vacuum pipe, right? So here, and by the way, this is just support. This is nothing. So I'm going to remove that. So here is our base. You'll see it's the only thing left. This is the base. So this is a single piece. And this base, this is where the the Roomba base is it's sucking all the air out of the system. So this will have a seal onto the bottom to the best of its ability. It's actually doesn't even need a seal technically because the seal is done on the adapter wall. So as long as there's a seal here, it's the only air into the entire Roomba base station. So technically, if this is airtight or close to airtight, most air, like 99% of it, that negative pressure will be coming up through this chimney, and that's where we want it to be. And so the most narrow point, the most narrow orifice on the whole Roomba solution is this point right here. And it's technically a little wider there than it actually is on the Roomba itself. It's a little tiny bit smaller on the bottom half of the Roomba. So I put in, let's go ahead and bring all this back in with the exception of the hull. 3 cyclones, let's take the lid off. Is 3 cyclones enough? I sure hope so. But we will certainly find out. I am technically running a little bit. I should have a 4 cyclone. If I want to match the potential that could come through this 40 millimeter hole, then I would have a 4 cyclone. I'm going to run it 1 cyclone short, and I just can't fit another. I mean, I'm sure I can figure out how to fit another cyclone here, but this is, proof of concept, right? It's a 4, 5, 6, 7, 8, 9, 10, 11 pieces, right? And they're all like loosely held together. The whole thing is, I guess you can call it modular. So, if we wanted to, change these cyclones geometry a little bit, then it's just a matter of reprinting one piece. And also all of this should print well in the 3D printer too. So I think this is a great start. And I will start by, and technically this is all one piece, right? The wall adapter and the base are all one piece. So I think what I'm going to do is I'm going to print this, fix that geometry there, print this, and test fit that. If it fits, print the rest of it. If it doesn't fit, scrap the project. Thanks for watching.